This is the second session of our quest to deploy secured Spring Web apps to various cloud providers. In our first session, we've deployed our simple Spring Web app to Railway cloud provider and established two continuous delivery pipelines, one for our master branch and one for our develop branch. In this session, we'll add Spring Security Framework to our web app to make it secure. We'll also discuss a high-level overview of the architecture of Spring Security Framework. Spring Security, as well as the Spring MVC we've looked at in a previous session, is another part of the Spring ecosystem that builds on top of core Spring Framework. It provides authentication and access control management features. And it's extremely large framework because it needs to account for various user needs. For our web application, we'd like the ability for our users to authenticate via their username and password. We'll also like the ability for our users to authenticate via the so-called social login. We'll use the OAuth 2 client features from Security Framework for that. Namely, we'd like the ability for our users to authenticate via their Gmail and Github accounts, and we'll see that Spring Security Framework provides first-class support for those two authentication providers. Let's add Spring Security dependency to our project. If we explore the newly generated POM XML, we'll notice Spring Security dependency has been added, but also timely Spring Security extras, as well as the dependency to test Spring Security. We'll copy the newly generated POM XML and replace our own existing POM XML. Let's start our app to see what changes have new dependencies bring. Our app did start. Let's try to hit localhost 8080. And we see that instead of our welcome message, we are greeted with a sign-in form. We haven't changed anything in our application. Yet, by adding a dependency, its behavior has changed. That is the opinionated Spring Boot auto-configuration kicking in. It secures everything by default and creates a default user for us. If we go back to our IDE, we see that we have security-generated password. If we try to use that in our application to log in with a user, we'll see we are greeted with a welcome page. If we get back to our application and have a look at the POM XML, we'll see that Spring Boot Starter Security has been added to it. If we drill down, we'll see that a part of it is Spring Security Framework Security Package. What Spring enables us to do is change logging levels for various packages inside our application. Let's go to Application Properties file and change logging level for this package. We'll set it to trace. Let's correct the typo and try to restart our app. And let's go back to the sign-in page and refresh it. If we get back to our logs, we'll see we have a host of new entries. We noticed we have a host of ordered filters executing, and the execution stops at something called default logging generating filter. Let's try to go to that class. If we scroll down, indeed we see our sign-in form. Although a lot of things seems to be popping out of nowhere, what's actually happening is Spring Boot Starter Security, since we didn't supply our own configuration, added a lot of what it considers reasonable defaults for us. Let's open Servlet Applications Architecture Diagram, which Tomcat is the implementation of, and we are using by including our Spring Boot Starter Web dependency in our project to try to understand what's going on. The way servlet applications process client request is by propagating it through something that's called filter chain. Filter chain is a list of filters, each one containing a bit of processing logic, which it runs on the requests, and once it's done, it passes the request to the next filtering chain. The way Spring hooks up into the servlet application architecture is by installing one of its own filters into the filter chain. From there on out, it processes every request by dispatching the request to the appropriate handler. This kind of single entry point to the application is usually called front controller pattern. To secure the request, Spring's filter chain proxy delegates the request to the security filter chain, which is again a list of filters that determine from the security standpoint whether the requests should go through or be rejected. You can find a comprehensive list of security filters inserted into Spring Security Filter Chain on Spring Security Reference website. You can provide your security configuration by installing your own filters into the Spring Security Filter Chain. But what you'll find is that the Spring Security team has already implemented common use cases. So what instead you can do, which we'll do in this tutorial, is to hook up into the extension points they provide. We'll notice that one of the filters installed into the Spring Security Filter Chain is username password authentication filter. And that's actually the filter that's being used in our form login scenario. We'll see on basis of this diagram that username password authentication filter, its job is to read the sign-in form for the username and password field and create what's called authentication token. It then passes the authentication token to something called authentication manager, which needs to conclude whether this user can be authenticated or not. Authentication manager doesn't directly conclude whether the user should be authenticated or not. Instead, it delegates the check to authentication providers, which we can have more of. Each authentication provider needs to tell what kind of authentication token can it authenticate, and needs to be able to call authentication logic, which will conclude on basis of given credentials whether the credentials are valid and whether the user should be authenticated. Let's go through the default configuration given to us by Spring Security. We saw that username password authentication filter was installed in Spring Security Filter Chain. Its responsibility is to generate username password authentication token by reading username and passwords from the sign-in form. It then passes username password authentication token to Authentication Manager. Authentication Manager goes through a list of authentication providers and asks each one, which one of you is capable of authenticating username password authentication token. In our default configuration, Spring installed DAO authentication provider, which can authenticate username password authentication token. And it's being called, and it delegates the authentication logic to user detail service, which will conclude whether the user is in a list of authenticated users and whether the credentials given in the sign-in form are valid. What you may find surprising by looking at this diagram is that username password authentication token is both passed into the authentication manager and both given out. And indeed, this is the case. Depending on where we are in the authentication flow, username password authentication token and in general other authentication token can represent two pieces of information. Before we are authenticated, they represent clump of data that needs to be authenticated. And if we are successfully authenticated, they represent user information of authenticated user, which will be placed in the Spring Security context and will be available for the rest of our application to use. Another important piece of the puzzle is user detail service. this will be our extension point, and this is the service that, given the username and password credentials, needs to conclude whether the user is valid and should be authenticated. Let's recap what's been included in the default Spring security configuration. Spring provided us with the in-memory user details service with one hard-coded user. It also provided authentication provider that delegates to this user details service. Then, Spring Security filter chain included username password authentication filter, which reads sign-in form and creates username password authentication token. It delegates the token to authentication manager, and the provider that can authenticate this kind of token is the DAO authentication provider. Let's return back to our application and have a look at the code. First, we'll have username password authentication filter. As every filtering chain, it needs to have do filter method. And we see that it attempts authentication. We see that this method reads username and password parameters from the request and creates username password authentication token. It then delegates the authentication to authentication manager. Authentication manager will go through a list of its providers and try to authenticate. We saw that DAO authentication provider was one of the providers installed. For DAO authentication provider, we'll see that it has a method supports, and this is where it says that it can authenticate username password authentication token. As any authentication provider, it also has to have a method authenticate. This is where the logic for authentication is contained. Next, let's have a look at the user details service interface. We'll see that it has one method, load user by username. And if we have a look at the hierarchy, we also see that user details manager is another interface that extends user details service, and it's more rich interface with the ability to create user, update user, delete user, change password. Now, if we have a look at the implementation of this interface, we see that Spring provides two implementations: in-memory user details manager and JDBC user details manager. JDBC user details manager is Spring Security the default implementation for relational database user storage. And in-memory user details manager is exactly what its name says. This is the class we'll use to implement our own in-memory users and to replace the default user provided by the default configuration. To briefly touch on JDBC User Details Manager, which is Spring Security own implementation of user storage, which uses relational database. And you might find this implementation sufficient for your needs. We will be storing our users in a database in a later session, and we'll use our own implementation just to demonstrate how to do it. Let's briefly return to the architecture diagram that we were looking at before to see what would be our first step in customizing our security configuration. We would like to replace the user that Spring gives us by default with our own couple of hard-coded users. In order to do that, we'll need to provide two things. One is our own custom user details service, which will have custom users. And the other thing is our own password encoder. We'll use it to encode passwords in our own users, and at certain point in time, the same password encoder will be used to encode password user provided in a sign-in form, and those two passwords will be compared for their equality. As a first step in our customization of our Spring security configuration, let's replace default user Spring gives us with something of our own. Let's start customizing our Spring security configuration. We'll make a package, call it security, and in there we'll have a security configuration class. It needs to be a configuration class, and it needs to expose two beans. One is password encoder. We'll use provided bcrypt password encoder. And the other bean it needs to expose is user details service. We'll call it in-memory users. And we'll use Spring's provided in-memory users details manager. We'll call it users, and we'll return those. We just need to populate it. Let's quickly remind ourselves what user detail service is. It's an interface that needs to return user details, and it's the only method it needs to implement. Let's see what user details is. It's also an interface that has a host of methods describing user. And if we check for implementation of user details interface in Spring Framework, there's already user and mutable user details. So in order to replace Spring's default user, we'll use a couple of hard-coded users. So let's get back to our security configuration. And in here, we'll provide two users, Bob, which will be a new user. Let's call it Bob. We need to provide a password. We'll encode it right away. Let's go with 1, 2, 3, 4. And we need to provide granted authorities for this user. We won't bother with that right now, so we'll just go with an empty list. And well, let's provide another user, call it Bill. This time we'll use a builder pattern from user class, and the user will have a username Bill. We'll have a password of, let's say, 321, and Bill will have authority. Let's give it the user authority. And we need to add those two users to our in-memory user details manager. We'll do that by creating a user. So we'll create Bob, and we'll create Bill. So that should be sufficient to replace the given user that's given by default in Spring Security by our own two custom users. So let's restart our app and try to log in with new users. If we refresh, we are again greeted with a sign-in form. This time we'll try to log in with Bob1234. And success. We see our new users are available and we were able to log in with one of them. Before we continue further, let me briefly touch on two things. One is the bcrypt password encoder we've used. It not only does it provide hashing, but it also provides a pseudo-random salt algorithm. So just by instantiating what was given to us by Spring Security, we are in great shape. The other thing I want to touch on is how does Spring handle user rights in the application. And if you have a look at the available methods, we'll see that there's roles and there's authorities. We've used authorities. And when you think of roles, you think of something a user is. A good role would be an admin, a user, a student, a teacher, so it's a noun. Authority, on the other hand, is something a user has rights to. So think of a verb. So user has a right to read, to edit, etc. By that account, I didn't really give this user appropriate authority. Something like read would be more appropriate, and I can give it a role of user. In general, if you want to make your life easier, you can think of roles as a grouping of authorities. So instead of giving read, write, edit authority to every user, what you usually have is a role that has appropriate authorities, and when you get a new user in your application, you'll assign a user a certain role, and transitively he'll get appropriate authorities. Let's for a moment return to JDBC User Details Manager provided by Spring, which is a user details manager you can use to save users in a relational database. And let's have a look at the schema Spring provides for us. We'll see that the tables it uses are users and authorities belonging to user. But also it has tables groups and group members, which are users belonging to a certain group. And group then has authorities. So you can think of these group tables as roles in our context. And by assigning a user to a group, you assign it to a role, and a role has authorities. And therefore, a user has the same authorities by belonging to a group. Let's get back to our security configuration, and there's one more useful thing we can do. The core Spring Security Framework raises events for successful authentication as well as the failure. And we can log those. First we'll add Lombok log4j annotation, and we need to expose a bean in our configuration class that will listen for application events, and we need to listen for authentication success event. Let's call it success logger. So our bean needs to return an event listener, and for now we'll just log success, and we'll display what kind of authentication has happened. We can get that info from the event itself, and since it's authentication success event, it has the get authentication method. Let's try to recap what we've done and try to set up some breakpoints to see how the authentication flow goes. We'll set up a breakpoint in our success logger, our DAO authentication provider. Now, DAO authentication provider has user details service as a field. So we want to check that our user in-memory detail service is being used. Let's set a breakpoint, let's say in retrieve user. And also we want to set a breakpoint in username password authentication filter, let's say in attempt authentication. We want to prove that this is the place where sign-in form is being read and username password authentication token is being created. Let's do it here. And let's try to run our application in a debug mode. Let's return to our application and try to refresh. We are greeted with a sign-in form. Let's try to log in with our user Bob1234. And we hit a breakpoint. It's at our username password authentication filter. And what we wanted to prove is this is the place where we are right now, that this is a token that's being processed by our filter, and it will generate the username and password authentication token that is currently unauthenticated. It just contains data that needs to be authenticated. So let's continue. Now we hit our DIO authentication provider. What we wanted, so here we are in the flow. What we wanted to prove that this authentication provider users are user detail service. And indeed we see that it uses in-memory user details manager with two users, Bob and Bill, we provided. So let's continue. And now we are at the success logger. And if we have a look at the source this time, here we are in our authentication flow. Authentication has been successful. And if we have a look, it's again username password authentication token, but this time it is authenticated. And it contains details about our users and its authorities. One thing we haven't discussed is how does Spring Security expose authenticated user in a case of the successful authentication to the rest of our application. And it does that through security context holder, which is, in the case of the servlet applications, global static object that you can access anywhere. And it's a thread local object. So, for instance, if we return to our home controller, we could go security context holder, get context, get authentication, and get authenticated user that way. In our case, authentication would be username password authentication token. While you can access authentication this way, you'll also find that Spring Security integrates with the rest of Spring ecosystem in other ways as well. So let's remove this and let's go back to our POM XML. What we see is that besides TimeLeaf starter template, we also included something called TimeLeaf Extra Spring Security 6. And what that is TimeLeaf integration into Spring Security concepts. And it provides two ways to integrate with the Spring Security. One is intended to check user rights and whether the user is authenticated. That's the security authorize. And the other one is intended to display info about the user. That's this security authentication. We'll talk more about TimeLeaf in one of our next sessions, but for now, let's just use features from Spring Security Dialect to display info about authenticated user. And if we go back to our index HTML, in case user is authenticated, we want to display info. Everything actually Spring provides about authenticated user, and for that we can use principal given to us by Spring. If we restart our app and go back to our login page, if we log in with Bob, now we see that we have info about authenticated user. Before we wrap up, let's run our test to check is everything okay. And we see we have a failure in our home controller test. We expected status 200, but we got 401. Let's return to our application and see what's going on. Well, firstly, let's go to POM XML and remind ourselves that by including Spring Security in our Spring Initializer, Spring Security test was also added. And if we go to our home controller test that fails, we can see that the problem is that Spring Security configuration by default made everything secure. And we need to somehow tell this test that authenticated user is performing a GET request to our home page. And the way we do that is by special annotations provided by Spring Security Test. It's with mock users. So we won't perform a real login with a real user. We'll just say the test framework that we want to use a mock user, so this GET should be performed by authenticated user. At this point, we don't care about its username or what are its authorities. So that should be enough for this test to pass. And let's just change the name to authenticated user should display home page. Let's run our tests again. In the future, we expect our home page to be accessible to all users, and we'll correct our tests when the time comes. But for now, we see the test that was previously failing is now passing. And that should be enough to conclude our session for now. In our next session, we'll discuss OAuth2 protocol and we'll add ability for our users to sign in with their Google and GitHub accounts. Until then, happy coding!